Problem number 3. Solve the quadratic equation by complete the square method. We have x squared minus 5x plus 3 equals 0. So the first step is to isolate those two first terms, and we can do that by subtracting 3 from both sides. So we have x squared minus 5x equals negative 3. Now let's use a formula which is b over 2 squared, or you remember the half the second coefficient squared, but the b comes from the standard form of quadratic equation, which is ax squared plus bx plus c equals 0, and the b is the negative 5. So plugging in negative 5 for b and then squaring it, we get 25 over 4. Now we have to add this number to both sides of the equation. So x squared minus 5x. And we do that to create a perfect square trinomial. So we're adding 25 over 4 to this side, and then also 25 over 4 to the other side. Knowing that this is a perfect square trinomial, we can factor it the simple way: x minus 5 over 2 squared. So it's always going to be the square root of the first term, which is x, then the first sign, and then the square root of the last term, so 5 over 2, and all that squared in factored form. And then on the right side, well, to be able to add and subtract fractions, we need to have the same common denominator, and in this case the least common would be 4, so I'm going to multiply top and bottom by 4. This gives me negative 12 over 4 plus 25 over 4. Now they have the same common denominator, and I can just subtract the numerators, and that leaves me with 13 over 4. So combined, this gives me 13 over 4. Now I can apply the square root method by square rooting both sides, and don't forget you get a positive and a negative answer. The square root gonna cancel out the square. We're left with x minus 5 over 2, and then over here on the right side, the 13 is not a perfect square root, but the 4 is, so I am able to split up the 13 and the 4, so I can take the square root of 4. That gives me the square root of 13 over 2. Now I'm solving for x, so I have to add 5 over 2 to both sides. And that gives me two answers. So one, we have x equals plus 13, but I don't even need the plus, and I can write 5 over 2 first plus 13 over 2, and then my other solution would be 5 over 2 minus 13 over 2. And then another way of writing it is, because they are both sharing the same common denominator, I can combine them and put them over one big denominator. So both of these versions of the solution are correct. It's a preference how to write it, and we have two solutions to this problem which would give a true statement.